Assalamualaikum and a very good day. This is a lesson for simple linear regression, which is chapter 6 in our syllabus. For this chapter, by the end of this chapter, you should be able to explain the concept of correlation and then use the Pearson correlation to calculate to calculate the correlation and interpret the results of the correlation. And then you will also be determine the regression equation and then interpret the parameter from the regression equation, which I believe you are familiar with y equal to mx plus c or y equal to a plus bx, where from this equation either these are the same. From this equation we know some relationship between y or x, okay, y and x, and we can relate this relationship to each other. You will be also will be exposed with the coefficient of determination and know the meaning of it. And finally, using the regression equation, you can predict the value of unknown variable, either is it independent or dependent variable. Let's start with a brief overview. So in engineering, science, or even in social science, people are interested to explore in relationship between two or more variables. If we know the relationship, we can relate and compare the variable and make conclusion from it. Let's say we interested to know the relationship between temperature and with the spread of COVID-19. With the spread of COVID-19, we will be so curious to know whether hot or cool weather affect the spread of COVID-19. Therefore, we start with collecting necessary data and predict the relationship between these two variables. What we want to know is the effect of COVID-19, whether it's spreading as the temperature increase or decrease. So let's say in X and Y axis system, our the temperature will be in X and the spread of COVID-19 in Y. So what is the main purpose is we want to know what will happen to the spread of COVID-19 as the temperature increase. Okay, whether as the temperature increase, the COVID-19 increase or decrease when the temperature increase. So this relationship between temperature and spread of COVID-19. So once we know the relationship of the two variable, which is temperature and spread of COVID-19, we also need to see the strength of the relationship. That is why we need to know about correlation analysis, where we interested to know whether we have a strong or weak or even no relationship at all. So regression analysis can be used to explore the relationship between two or more variable. For this type of study, we are study two variable, which is spread of COVID-19 and also temperature. But actually, we also can find more variable. For example, spread of COVID-19 with temperature and also with humidity, which is now it become three variable. But in this chapter, we will focus on relationship between two variable only. Let's explore what is variable. A variable is an object, characteristic, or any other type of category that the researcher or engineer want to study or measure. So there is two type of variables. One is independent variable, another one is dependent variable. So independent variable is a variable that is manipulated or controlled in the study or experiment to test the effect on the another variable, which is we want to test the effect of dependent variable. Meanwhile, the dependent variable is a the variable being measured and tested in a study or experiment. So in a two-dimension axis, the independent variable will be in x and dependent variable will be at y axis. So let's look at this example. Some of the example of independent and dependent variable are shown in the table below. So example 1, number of registered vehicles is independent variable and number of road accident is dependent variable. We can see here number of accident depends on number of registered vehicle. As more vehicle registered in the system, uh, as more vehicle registered in the system, it will result more vehicle will be on the road. Therefore, it will affect the number of road accident. Okay, so let's look at example 2. Now, voltage of the electricity is independent variable and speed of motor rotation is a dependent variable. We can see that turns in this case speed of motor rotation depends on voltage of the electricity. Increase in voltage will result more power and speed to the motor rotation. Okay, so next example, example number 3. Number of employee now is an independent variable and tons tons of mole produced is a dependent variable where we can find that tons of mole produced depends on number of employees. As the number of employees increase, it will produce more mole in the production. And lastly, temperature used is independent variable and strength of the steel is a dependent variable. Which we know that we can see that strength of the steel depends on the temperature used. high temperature will produce different quality of steel compared to if it is used lower temperature. We using different temperature, we will have a different quality of the strength of the steel. So we want to know if the temperature increase, what will happen to the strength of the steel. Okay, let's look at this exercise. State the independent variable and dependent variable for each of the following statement. For you have three questions. So question 1, A, the weather temperature in Celsius that affects the ice freezing rate at the ice planet. Ice plan. Okay, from here we can see that the ice freezing rate depends on the weather temperature. So therefore, weather temperature is independent, which is in x-axis, and ice freezing rate is a dependent variable. Okay, this one will be your x-axis. This one will be in your y-axis. Okay, next, an electric utility is interested to study about relating peak hour demand and total monthly energy usage during the month. Okay, for this exercise, we can see that the total monthly energy usage during the month depends on peak hour demand. Therefore, the independent variable is peak hour demand and dependent variable is total monthly energy usage during the month. Okay, so this will be your x-axis and this will be your y-axis. This variable is in y-axis. Okay, last exercise, C. Okay, an experiment is performed to determine the effect of temperature on the strength of normalized steel. Okay, for this case, you can see that the strength of normalized steel depends on temperature used. Therefore, the independent variable is temperature used, and then the dependent variable is strength of normalized steel. So again, this is independent variable is in x-axis. This is referred to y-axis. Now let's look at what is correlation. So correlation is a statistical term that used to measure the strength, okay, of the relationship between two variables. A strong or high correlation means that the two variables have a strong relationship with each other. Okay, whether your variable in x or y have a strong, weak, or no relationship at all. While a weak or low correlation means that the two variables are less related to each other. Here we can use scatter diagram as one of the statistical methods to identify whether a relationship between these two variables exists by using graph, which we will plot the available data. The pair variable x and y are plotted on the graph where the independent variable is labeled, as again I say, independent variable is labeled on the x-axis and dependent variable is labeled on y-axis. So let's look at the type of correlation that we have. So there is 5 types of correlation between two variables. Okay, so we have perfect positive correlation. So here as the x increase, the y also increase. So this is called perfect positive correlation. Okay, you can see all the point lies in the same line. Okay, and then you have perfect negative correlation. So as x increase, y will decrease. Okay, and you can see that you will have all the points that are for two variable in a line. So it is a perfect positive or perfect negative correlation. Okay, next we have positive correlation. So we have the point have a uh, positive positive correlation. Okay, lies in a line. Lies around the line. Okay, but all of the point is near to the line, so it's a positive correlation. And then we have a negative correlation. We have a negative correlation. So the strength of this, we can just look by just looking at the regression line. Okay, so all the point it's near the line, so we can just say this is about it's a strong relationship. Okay. Okay, but this is show that there is no pattern at all. So there is no correlation between these two variable x and y. And again, this is no correlation graph because we can see that this is not a straight line. So it doesn't show the relationship between x and y, doesn't see any correlation on it. Okay, let's look example 2. A researcher conduct a study on the performance efficiency of 10 machines in a electronic company based on the usage duration for every machine. The results are shown in the table below. So you need to construct a scatter plot and identify the independent and dependent variable. Okay, state the type of relationship. So from here, what you can see that the performance of efficiency depends on usage of duration of the machine. Therefore, usage duration is independent variable in the x-axis. Meanwhile, the efficiency of machine is dependent variable in the y-axis. So you must know whether your variable is independent or dependent variable. Okay, once you know the independent variable is usage duration and dependent variable is the efficiency of machine. So plot all the point and you can see the pattern is a straight line. Okay, so this is considered a negative correlation between usage duration and efficiency of machine. Okay, you can see the pattern from the graph. Okay, let's look at this exercise. Steel is normalized by heating above the critical temperature, soaking, and air cooling. An experiment wants to investigate the effectiveness of time consuming in heating on the strengthness of the steel. Strengthness of the steel here depends on time consumed of the machine. Therefore, time consumed is independent variable which is in x-axis Meanwhile, strength of steel is dependent variable in the y-axis. So we can say that independent variable is time consumed in minutes and dependent variable is a strength of steel. So as we plot the data, we can see the pattern of positive correlation between time consumed and steel strength. Okay, now let's look at linear correlation coefficient. So relationship between two variables can be identified using a scatter diagram. However, there is no specific way to determine the strength of the relationship. We just can see all the point in the scatter diagram, but we cannot say whether you have strength, moderate, relationship between the two variable. So linear correlation coefficient is one of statistical method that provide us with the measure to evaluate the strength of the relationship between these two variables. So the mathematical formula for the Pearson product moment, this is a product moment correlation coefficient. Okay, the value of the correlation lies between uh, positive 1 to from negative 1 to positive 1, which which indicates whether it have negative or positive relationship. Okay, let's look at the formula. So the value of R describe the strength of the relationship. So the correlation of coefficient of R is calculated as below. So once we know the value of X and Y, okay, we find all the information which is and refer to number of observation. R here is actually, you know that you are finding a correlation coefficient using a Pearson product moment correlation coefficient. Okay, this formula is called Pearson's product moment correlation coefficient. Okay, by looking at this equation, we just substitute all the available information and refer to number of observation, summation x and y, meaning that you need to multiply x and y and then find all the sum of the product of x and y. Okay, summation x here meaning that you need to find the summation of all value of x, and summation of y, find the value of all the summation of y, total number of total value of y. Okay, and then we have, okay, here again the number of observation now is summation of x squared, so find the x squared and also y squared. So find x squared, each of the x squared, and then total up everything, and then you will get the summation of the square value. Okay, whether we want to find the summation of square value for x or y. Okay, so this one meaning that again, the square of the sum of all value of the variable x. So yang ni silap. This one is wrong. The square should be outside. Summation of, okay. Okay, the square of sum of all the value of variable x or y. Okay. So this refer to strength of the relationship between the two variable. So we will calculate the R value, and value will be we want to know what is the value of R represent our correlation. If we get negative 1, meaning that we will have a perfect negative linear correlation. Okay, if our value is between negative 1 and negative 0.7, or here we have a this one will be 0.1 0.7 to 1. So both of these are strong, whether strong negative linear correlation or strong positive linear correlation. So if we get negative 1, meaning that perfect negative linear correlation. If we get positive 1, meaning that we have perfect positive linear correlation. Okay, so if our R is between 0.3 and 0.7, whether it's negative or positive, meaning that we have moderate. Okay, so moderate negative. For positive, meaning that moderate positive linear correlation. And then for R in between of 0.3 and 0.1, okay, if it is negative, we have weak negative linear correlation. So if it is positive, we have weak positive linear correlation. So if our R is equal to 0 or approaching to 0, it means we have no correlation or no non-linear correlation. Okay, if our value of R equal to 0. So let's look at example 3. A group of engineers want to determine the stress level of which a wing component on an aircraft will fracture for a given fractured toughness. Table below show the temperature and impact energy data tested on temperature steel alloy. Calculate the coefficient of correlation R for the data. Then interpret the result. So we have temperature and impact energy. So we need to determine what is our X or Y. So here we found that the impact energy depends on temperature. Therefore, the temperature will be in x-axis and impact energy will be in y-axis. Okay, so it is important for you to know where is your what is your x-axis variable and what is your y-axis variable. So here the independent variable is temperature and dependent variable is impact energy. Okay, now find all the important value for this formula. Okay, so you want to find summation of xy, summation of x, okay, summation of y squared, summation of y, okay, and so on. And we know that the total number of data is 15. So total number of data is 15. 1, 2, 3, 4, 5 until you get. Now overall you have 15 data. So n equal to 15. Substitute all in the formula and you get 0.9356. So from this value, you can compare with the table before this. So you get 0.9. So this is within this range. Okay, so we have a strong positive linear correlation. Okay, so there is strong positive linear correlation between temperature and impact energy. As the temperature of the component increase, the impact of energy also increase. So in other way, we can say as the temperature of the component decrease, the impact of energy also decrease. Okay, now look at exercise 3. Steel is normalized by heating above the critical temperature, soaking and air cooling. An experiment wants to investigate the effectiveness of time consuming in heating and strengthness of the steel. Okay, so we have the data of time consumed and also the strengthness of the steel. What we can say that we found that the strengthness of steel depends on time consumed. Therefore, time consumed will be in x-axis and strengthness of steel will be in y-axis. Once you determine your variable x and variable y, so you proceed to the calculation of r. Okay, so find all the important value and substitute in the formula. So you get again 0.989894, which is positive, and this is in the range of 0.7 and 1. Okay, so your R is between 0.7 and 1. So there is a strong positive linear correlation between the time consumed and strengthness of the steel. So as the time consumed increase, the strengthness of the steel will increase.